Find the area of each of the following shaded regions. Assume all arcs are circular with centers marked. Okay, starting with A. We're looking for the shaded region, and we've got a large circular, mostly shaded region, maybe mostly, and we've got two smaller circles that are not shaded. So what we need to do for A is we need to figure out first the area of the large circle. Okay, so in order to figure out the area of the large circle, remember that's A is equal to pi r squared. Okay, we need to figure out what the radius is. Okay, we're given the radius of the smaller circles, that it's 6. So we can deduce that if this is 6, this looks to be the center of the circle. If this is 6 from here to here, then this is also 6 from here to here. Okay, so from here to the center, all the way, would be 12. Okay, so we'll assume that this has a radius of 12 centimeters, which means that the area of the large circle is equal to pi times 12 squared. So 144 pi. Okay, and now let's find the area of one of the small circles. There are 2 of them, so when we find that, we'll have to subtract 2 of them away from the larger one because they're not shaded. And we're given the radius, so that's equal to, area is equal to pi times 6 squared. So that's equal to 36 pi. So for A, we have 144 pi minus 36 pi minus 36 pi. Okay, and that is going to end up being 72 pi. Type it in your calculator here. 144, leave the pi off, minus 36 minus 36. The pi just gets carried along. So that's 72 pi is the shaded region of A. All right, let's take a look at B. So for B, we have what looks like an ice cream cone here. We've got a semicircle, so half a circle with radius 5. We've also got a triangle here. Now we could add up this entire triangle and then cut it in half if you wanted. That would be this would be the base and this would be the height. But we already know that if this is 5 centimeters here, the radius of that semicircle, then this is 5 as well. So we can just say, well, that has a base of 5 and a height of 10. Okay, so for B, first figure out the semicircle. The semicircle is pi r squared. Pi times 5 squared equals 25 pi. And now for the triangle, and this is the shaded triangle. Let me write that down. Shaded triangle, not the entire triangle, which includes both. It's just the green one there. Okay, so it's shaded and it is 5 for the base, 10 for the height, and area is equal to base times height over 2, so that is equal to 5 times 10 over 2, which is 25. You add those together, shaded semicircle, shaded triangle, and you get 25 plus 25 pi. All right, and let's go ahead and do C. Okay, C got the yin-yang sign here. What you should notice about C is that this and this appear to cancel each other out. Okay, so if you laid this region over here, it's the exact same. So this is still going to be just a semicircle. Now you could do a little more math on this, and you could take the entire circle, and then you could add in this and subtract that. But that's really too much work for this. If you see that this area is equal, we'll call this area x and area x. They're the same. They cancel each other out. So this is going to be just the area of a semicircle. And the area of a semicircle is A is equal to pi r squared. So that's going to be equal to, what is the radius of this entire circle here? Well, if this is 6, and 6 plus 6 is 12. So the radius of this big circle is 12. So that is pi times 12 squared. 144 pi is your answer. All right, now for the last one. This one's going to be a little bit tougher. Okay, so for this one, we've got this square, and then we've got these what looks like petals. Now notice that it says assume all arcs are circular with the centers marked. Okay, so what that means is that this right here is going to be the arc of a circle. Okay, so let me write that out. Okay, so I'm going to do it a little differently than what they have written there. I didn't put this upper region in there, so I'm drawing basically this square here, and I'm showing you the lower white unshaded region, but I'm pretending that this is shaded. So I'm pretending that it goes all the way shaded up here. Okay, so let's see if we can figure out what the shaded and unshaded part of this is. Okay, so what is the side length of this square? Not the big one, just this one. Okay, so we know that the side length of the big one is 40, right? Looks to be half of that. So we know that this right here and this right here has to be 20. So this is 20 by 20. That's centimeters. Okay, so I know that the area of the square, the entire square, shaded and unshaded together, is 20 times 20, or 400. Okay, now how do I figure out what this is? Well, this is a circle, right? And if I had another one here, and another one here, and another here, would that make a full circle? Let me draw it a little bigger and show you what I mean. Okay, so you split this up into 4 squares. Each one of them looks like this, so I would do this fourth of a circle here, fourth of a circle here, here, and here. Okay, so that is this, except extrapolated to the entire larger square. So all this stuff is shaded. Okay, so you can see that this represents this, and this is a fourth of a circle, right? This shaded region, this is the big circle, this represents a fourth of that. So if I can figure out what the area of this huge or larger circle is, then I can divide it by 4 and get that. Okay, so what's the area of this large circle? That would be, well, we need the radius. What's the radius of this circle? Look at this square here. So the radius of this circle, well, we know that across here is 40. Okay, so half of that is 20. So R of this circle, let's even call that big R so I don't get confused here, is 20. So the area of this whole thing is equal to pi times 20 squared. Okay, which means the area of the smaller one, just one section of that, is this divided by 4. So the area of the quarter circle is equal to, well, it's equal to this time, or divided by 4. So we get pi times, let's see, what is that, 400 over 4? So 100 pi. Okay, now how did that help us? Because it doesn't really look like this, looks much like this yet. Well, what that told us is, if you take the entire area of this little square here, it's 400. If you take the area of this shaded quarter circle here, it's 100 pi. So now we can figure out what this little white area is. Okay, this little white area is the difference between the entire square and the shaded region. So the white unshaded area is equal to 400 minus 100 pi. Okay, so that's important. It's not the answer yet, but it is important. Okay, because what we really have is not just this, but we have this going on as well. So we have two white regions, right? So this is the shaded region. Okay, so how would I figure out two of the white regions? Well, I have this region and this region, so I have the circle, or the semicircle, which we found to be 100 pi. Okay, and I have each one of these that I found to be 400 minus 100 pi. Okay, so what I'm going to do is take the area of the square to figure out this area of the square, and this is a small square, is equal to, what was it again, 400? Okay, and I'm going to subtract the two white regions away from the area of the square. That will leave this little area right here. So the area of the square is 400, and I subtract this white region and this white region. What were the white regions? Here they are. Okay, so I have 400 minus one white region, which is 400 minus 100 pi, and then minus another one, minus 400 minus 100 pi, running out of room there, which is in essence 400 minus 2 times 400 minus 100 pi. So area of the square minus 2 of the white unshaded regions. That gives me 400 minus 800 plus, that's 800, not 8,000. 400 minus 800 plus 200 pi, which is going to be 200 pi minus 400. Okay, so this is the shaded area. Let me write that down. Shaded area of one small square. Okay, so going back to the original problem, what we found is that 200 pi minus 400 represents the shaded area in this box right here. Okay, 200 pi minus 400. Now, in order to get the shaded area in the entire bigger square here, what would I do? Well, how many of these little squares do I have? I have another one here, and another one here, and another one here, and they are all identical. So to figure out the entire shaded area, this will be our final answer, shaded area total. We multiply this answer by 4, since we have 4 of those little squares. So 4 times 200 pi minus 400 equals 800 pi minus 1600. And that is in, what was that in, centimeters squared. And that's it.